A voice agent can answer quickly and still feel painfully slow. Imagine a customer saying, "Move order Juniper 583K to Friday," and then pausing. They add, "After 6 in the evening." The agent begins answering, but the customer interrupts, "Wait, Saturday, not Friday." Then comes one more correction. "Juniper 583K, K, as in kilo." That pause, added constraint, interruption, and corrected identifier can expose an entire voice architecture. Today we will run the same conversation through 3 designs and find where the pause comes from. Architecture 1 is the classic cascade. Speech to text, language model, then text to speech. Architecture 2 is a streaming cascade, where those stages overlap instead of waiting for complete outputs. Architecture 3 is native audio, where one audio-capable model handles the conversation more directly. Native audio can still operate in turns, or run full duplex and listen while speaking. The useful question is which design handles pauses, context, interruptions, and corrections without losing control. First, separate 4 clocks that people casually call latency. Clock 1 is end-of-turn detection, when the system decides a user is done. Clock 2 is time to first useful audio, not merely the first sound. Clock 3 is interruption response, how quickly outgoing speech stops when a user cuts in. Clock 4 is correction recovery, when the system reaches the revised task state. Start with the full-turn cascade used by many early voice assistants. The system waits for an endpoint, transcribes speech, reasons over text, then synthesizes the answer. The pause after Friday can look like the end of the request. Commit too early, and the agent plans before hearing after 6. Wait too long, and the customer hears dead air despite fast individual components. The delay is several small waits placed end-to-end, not one giant pause. The cascade also has real strengths, and dismissing it as outdated would be a mistake. Text creates boundaries teams can inspect, redact, store, route, and replay. Recognition, reasoning, tools, policy checks, and synthesis can be evaluated or replaced separately. When Friday becomes Saturday, the transcript shows exactly which detail changed. The cost is that timing, emphasis, hesitation, and overlap may be compressed into text or lost. OpenAI's July 8th GPT-Live announcement describes its original ChatGPT voice cascade as slower and sometimes stilted, with information potentially lost between models. That is one company's product history, not a universal benchmark against every cascade. A streaming cascade keeps the modular boxes but moves partial results before the turn is complete. Recognition emits provisional words, the model prepares, and synthesis can start from early text. On the Friday pause, the system can prepare an action while withholding commitment. When after 6 arrives, provisional state updates instead of restarting the pipeline. The Saturday interruption must cancel pending speech and revise the tool plan. The K clarification must replace every stale partial identifier downstream. But teams must decide what may be speculative, spoken, canceled, or committed. Amazon Polly's March 26 bidirectional streaming announcement demonstrates one piece of this pattern. It sends text incrementally and receives synthesized audio over a persistent HTTP2 connection. In Amazon's vendor test, 970 words completed in 70,071 milliseconds instead of 115,226. The test used 7,045 characters, Matthew, MP3 at 24 kHz, US West 2, and a simulated model emitting one word every 30 milliseconds. Amazon reported 39% faster full audio delivery and reduced 27 requests to 1. That measures completion of a long passage, not conversational time to first audio. It is not native speech to speech and should not be ranked against unrelated vendor tests. Now move to native audio in a turn-based operating mode. An audio-capable model can process speech cues directly without forcing every meaning through text. That can preserve more rhythm, tone, and intent than a strict text bottleneck. But an end-of-turn wait leaves the Friday pause facing the same cut-in or wait decision. OpenAI says its earlier turn-based voice model reduced latency compared with the original cascade. It also says silence or background noise could cause bad turn detection while waiting for the user to stop. Native audio may improve the path inside a turn while leaving the boundary as the dominant pause. Full duplex changes the interaction contract instead of merely shortening the pipeline. The system continuously processes input and output, so listening need not stop while speaking. It can treat Friday as provisional, absorb after 6, and begin a cautious confirmation. When Saturday arrives, it can stop, update the slot, and continue from corrected state. When K is clarified, it can replace only the uncertain identifier. OpenAI describes GPT-Live as listening and speaking simultaneously, making interaction decisions many times per second. The company says deeper reasoning or web search can be delegated to a background frontier model. Those are vendor descriptions, not proof that full duplex makes every task faster or more accurate. Current product availability is easy to misstate, so dates matter. GPT-Realtime-2 was announced May 7th and is available through OpenAI's real-time API. OpenAI reports a 15.2% big bench audio gain over GPT Realtime 1.5. That is a vendor comparison with its prior generation, not an independent cross-vendor ranking. GPT-Live was announced July 8th for rollout in ChatGPT. Its announcement says API access is coming soon, so GPT-Live is not an available API at this cutoff. Google announced Gemini 3.1 Flash Live on March 26th in developer preview through the Gemini Live API. It is another first-party live voice case, not a score to place beside different OpenAI tests. Architecture choice begins with auditability versus naturalness, but neither side owns either quality. A cascade offers a convenient transcript boundary, yet transcripts omit some tone, overlap, and uncertainty. Native audio can preserve richer cues, yet production still needs tool logs, state changes, consent, and retention rules. A useful system records what it heard, believed, said, and asked an external tool to do. For Juniper 583K, Friday should be provisional, Saturday the correction, and K confirmed. Natural conversation and accountable operation are system outcomes, not magic model properties. The second trade-off is control versus complexity. A full-turn cascade offers sharp component boundaries and rollback points, but serializes delays and compounds errors. A streaming cascade preserves those boundaries while adding partial transcripts, speculation, cancellation, and commit rules. Native turn-based audio simplifies the visible path, yet still needs end-of-turn detection and dependable tool orchestration. Native full duplex handles user interruptions naturally, but simultaneous listening, speaking, reasoning, and tools create hard concurrency tests. The number of boxes can fall while the number of states rises. Choose architecture by failure modes your team can observe, reproduce, and recover. Do not trade a visible pause for invisible state corruption. Here is a practical selection rule. Choose full-turn cascade when precise text records, approval gates, interchangeable components, or strict isolation dominate. Choose streaming cascade when lower perceived delay matters, but explicit text stages should remain. Choose native turn-based audio when richer speech cues matter and clean turns are acceptable. Choose native full duplex when interruption, back-channeling, and rapid correction define the experience. Many systems will be hybrid. Live audio, explicit tool schemas, durable state transitions, and a text audit shadow. Then test the conversation you expect, not a polished one-turn demo. Measure time from meaningful input to useful audio, not connection setup. Measure false early endpoints and long waits across pauses, accents, microphones, and noise. Measure interruption stop time and whether the revised answer uses new information. Measure correction retention by checking Saturday after 6 and Juniper 583K. Measure task success, tool errors, transcript accuracy where relevant, and audit completeness. Run identical scenarios under comparable network and tool conditions. Keep vendor numbers inside their original test boundaries instead of inventing a universal leaderboard. So why does voice AI still pause? Sometimes it is deciding whether the user finished. Sometimes serialized stages wait on one another. Sometimes streaming holds a speculative answer until commitment is safe. Sometimes the pause sits outside the model, inside a network, policy check, or tool. Cascade gives legible boundaries. Streaming buys overlap with more state, and native audio buys richer interaction with new orchestration demands. Full duplex fits interruptions, but it is not a free pass on correctness, control, or latency. If the final state says Saturday after 6, keeps the old slot until confirmation, and preserves K as kilo, the architecture did its job. Pick the design that recovers from the messy middle, because that is where real voice products stop being demos.